to Vedantu NEET English. I'm Diksha Ma'am, your chemistry master teacher. And students, today we are going to do conformers of alkane, where we are going to see conformers of methane, conformers of ethane, propane and butane, what is gauche, what is anti, what is the stability, and how to calculate stereoisomers, how to calculate stereocentre, and all these things bacha we are going to do today. And also the projections like Newmann structure, like Sawhorse, what is wedge dash, all these structures bacha, Fisher structure also we are going to do today itself. So everyone in the chat box, am I live? Am I audible? Am I visible to all of you? Everyone here, am I visible? Am I audible? So today we are going to do all these things in a very crisp, short session. And as you all know, this is specially mentioned in your NEET syllabus about the conformers, okay, about the conformers. So do not skip this topic, okay, very important, very simple topic it is, okay, very important yet very simple topic it is. So everyone in the comment section, should I start the session? Everyone in the comment section, should I start the session? I want green hearts in the chat box. Everyone, green hearts in the chat box. Should I start the session? Guys, all the students in the chat box, should we start the session or not? Guys, should we start the session or not? Yes, bacha, should we start the session or not? Hello, hello. Okay. Why the persons are so less? I specially took this session for you guys. There were so many comments that ma'am, we want you to do this lecture, we want you to do this lecture about conformers and all that. And now, what I see now, this is how you break my heart. This is how you guys break my heart. That's sad. That is actually very sad to know that, right? Because I thought that you are requesting, so I'll deliver that for sure. But now what I see here is that you just type it in the comment and you see that because you know the thing is that when you write something, you feel that the teacher will not take you seriously because it's an online platform, it's a YouTube platform. But I took you seriously. That is my mistake, is it? I took you seriously. I thought, okay, you are asking me to do this lecture. That's why I, specially morning only I had one session. This is the extra session that I took specially for you, right? But now what I see, this. Okay, no worries. This is how you broke my heart. No worries. But I am going to teach you anyway. So guys, today we are going to firstly see the projections here. Let us see the projections, everyone. What are the projections? So guys, we have mainly 4 projections in organic chemistry. Okay. So what is the name of this first projection, everyone? What is the name of this projection? This is the sign of BMW, no? So BMW is owned by the Newmanns, okay? The youngsters, the Newmanns. So what we are going to write? BMW owned by Newmann. So here we are going to write a Newmann structure. Okay, this is Newmann structure. Now what is this structure, beta? This is the Newmann's projection, not structure. This is Newmann's projection. Now what is this structure? What is this structure? This is called, wait. This is called, not wedge dash, this is called Sawhorse, okay? This is called Sawhorse projection, right? Then we have this one, this is called Fisher projection. This is called Fisher projection. And this thing is called, this is called wedge dash projection. This is called wedge dash projection. Now let us see how do we define all these projections. So firstly that we are going to see is Newmann projections, okay? Firstly that we are going to see is Newmann's projections. For Newmann's projections we have this one. See, what does this mean? This simply means that you have 3 atoms, okay? You have 3 atoms that are linked to this carbon, okay? You have these 3 atoms that are linked to this, okay? This simply means that you have one atom here. This is first atom, second atom, third atom. And these dotted line means that we have another set like this in the back side. Okay, in the back side we have same set of atoms. Okay, not same set of atom, but the same alignment of atoms in the back side. Like this is the atom, and back side we have the same alignment of atom, right? This is called, bacha, this is called Newmann structure, where this represent the front wedge, this represent the front atom, the solid represent the front atom, and this dash represents the back atom. Okay, this represents the back atom. So this is what we are going to see here, that this is the front atom and this is the back atom here. This is the front atom, that is the back atom. Okay, just visualize this like this. Okay, this is the front atom, this is just how you see that projection. If you see that projection in the form of Newmann's, what you will see, this is the front atom, this is the back atom. Okay, this is the front atom. At this point I won't be able to see, are you able to see this back one? Are you able to see this back atom? No, you're not able to see, right? You're not able to see clearly this back one, right? But if I say like this, now you are able to see both of these. Now this is called Newmann's, and if I write it like this, this will be Sawhorse, this will be Sawhorse, right? And these two projections, the two molecules are same. Okay, the molecules here are same. It's just that there is difference in the how we see that. Okay, this is the Newmann's projection, this is the Y here, this is the Y here, right? And this is the backside Y and this is the backside Y, right? Okay, yes students. Now for example, you have something like this. For example, you have something like this. You have something like this. What does this mean? What does this mean? This means that you have one carbon which is actually like this, and the other carbon is like this, and the backside carbon is like this. It has atom here, it has atom here, it has atom here, right? So the alignment is different here. Okay, the alignment is different, so hence here the structure is going to be different. Okay, if this is A, this is B, this is C, this is D, this is E, this is F, so this is going to be this is the Y here, right? This is the front Y. Everyone here, draw this. This is going to define this line is going to define the length between this carbon or this atom and this backside atom, right? This is how it is going to define it. This is the line between these two atoms. Now the front atom is attached to this A, E and C. So I'm going to write it here, A, E and C. And the back atom is attached to F, B and D. So I'm going to write here F, B and D. Okay, this is the Sawhorse projection and this is the Newmann's projections, right? Okay, now bacha, we will come to staggered and all that, right? But before that, see this. Okay, now bacha, now you have Fisher projection. This is the Fisher projection. Simply this is the front atom, this is the front atom, and this is the back atom. This is the front, this is the back, right? This is just a way of representing it, right? This is just a way of representing it. For example, if I want to represent this atom, if I want to represent this thing in the form of Fisher projection, right, that will be defined something like this. Okay, that will be defined something like this. Okay, now next thing is wedge dash projection. So this is the wedge dash projection. Now the main thing here is that how to convert something into wedge dash projection. Okay, how to convert something into wedge dash projections. Everyone here see this very carefully. How to convert something into wedge dash projections. Very important, bacha, very important. For example, you have something like this. Okay, you have something like this. This is A, this is B, this is C and this is D, right? Convert this into wedge dash. This is the wedge dash. Convert it into your Newmann structure or Fisher projection, right? Convert it into Fisher projection, right? Convert it into Fisher projection. How are you going to draw it? This is the Fisher projection. Fisher projection, it has just one atom here in the center, right? Draw the plus sign here. See how you're going to do this by thumb rule. Okay, the lines, this is the front view, this is the front view and this is the back view. Okay, this dash means the back view, the back atom, right? For example, something is in front, right? I can see this. This is the for me, this black one, or I would say this white marker, or I would say this white marker is in front side and this gray one is in the back side. Okay, so what I am going to say here, that this is the front side, this is the back side, this is the front side, this is the back side, right? So what I am going to write here, that the front side, okay, that the front side, bacha, everyone see this very carefully, that the front side, this is the back side. Okay, now you are clear on this, and these two, A and B, are on that plane. Okay, these are on that plane. This is the front side, this is the, for example, this is your front side, this is your back side, and something that is lying here, that is lying here, this is in the plane. This is front side, back side, this is in the plane. Front side, back side, in the plane. Understood this? Okay, front side, back side, in the plane. Now let us draw the Fisher projection here. Very simple. So the atoms that are on the plane, that means that are drawn by just single line, they will be at this position, that is top and bottom. Now which will be on the right side, and those that are out of the plane, that means the front side and the back side, are going to be on the left or the right side of the Fisher projection. Now let us see which is going to be on the front side, which is going to be on the back side. Now bacha, let us see which is going to be on the front side, which is going to be on the back side. See, where you have this thumb, okay, this is your thumb, right? This is A, this is B, this is your thumb. Where you have this thumb, the wedge, this is the wedge, okay, this is wedge, and this is dash, this is dash. Where you have the thumb, the wedge is going to be on that side. Where you have the thumb, the wedge is going to be on that side. Okay, so this D, that is the wedge, is going to be on that side where we had the thumb. Okay, the wedge is going to be on that side where we had the thumb. Everyone, the wedge is going to be on that side where we had the thumb here. Okay, so very simple, this is how you're going to draw it. Now everyone, for example, you have something like this. You have something like this. Okay, now tell me how you're going to separate this. Now everyone tell me, this is A, this is B. Okay. Now everyone, this is A, this is B. Everyone, how we are going to handle this? Yes everyone, C will be on the left and D on the right. Very good. Okay, so simply the thumb is on the, okay, simply just draw this plus sign here. Just draw this plus sign here. You see, the thumb is on the right side, right? Okay, the thumb, firstly draw the thumb here, draw here A, this is the B, right? This is A, this is the B. After that, the thumb is on the right side. Everyone, wait, the thumb is on the upper part, right? So it will be BA. It will be B and this will be A. Right? The thumb is on the left side. So wedge will be on the left side. This is the C and this is the D. This is how you are going to convert wedge dash into the Fisher projection. Now, for example, you have something like this. You have something like this. Now, ma'am, what we are going to do? Now, ma'am, what we are going to do now? Now, everyone, the thumb is neither on the left side nor on the right side. Now, bacha, what you are going to do now? Everyone in the comment section, what you are going to do now? Now, bacha, very simple. In the similar manner, just rotate this, okay? Just rotate this, something like this. Just rotate this to this one. Just rotate this to this, okay? How are you going to rotate it? Rotate this AB into this, okay? So just draw this AB here, okay? And the dash will be same here. This will be the D part. This is going to be the C part, okay? The dash is going to be the C, right? Okay, everyone, the dash are going to be same here. What you are asking, bacha? Will be also, no, bacha, I am going to give you some practice questions, right? Some practice questions that are from the PYQs only. Right? Okay. Now let us see this. How to convert it into Fisher projection. Everyone here, how to convert it into the Fisher projection. See this. This is the Fisher. This is the Fisher. Yes, bacha. Now we are going to do AB. This is AB. So this is A and this is B. This is A and this is B. Right? So the wedge is going to be on that side where you have the thumb. The thumb is on the right side. So C will be on the right side and this is going to be something like this. So is this clear to everyone here? Is this clear to everyone here? How to convert this projection to this projection, right? Everything is same here, right? All the projections doesn't mean that the compound has changed. The compound is same only, right? The compound is same, right? Okay, so now bacha, let us talk about another thing here. Just define this thing, then we shall move ahead with conformations. I have one more example for you. Okay, for example, I have something like this. Okay, I have something like this, right? Okay, for example, this is chlorine, this is bromine, this is H, this is CH3, this is H, this is H. Okay, so now, or you can write it here CH3. Okay, so now draw the Fisher projection here. Draw the Fisher projection for this structure. Draw the Fisher projection for this particular structure. Just draw the line here, because you have two atoms here, 1 and 2 atoms here. Draw two lines here. You have drawn two lines. Yeah, everyone, you have drawn two lines. Now next what we are going to do, you have drawn two lines here. Next thing that we are going to do here is, here we have chlorine, here you have bromine. Right, okay, so bacha, see this, we are going to take this whole thing as a thumb. This is the first on the plane, this is the second on the plane, this is our thumb. The lines, simple solid lines are the thumbs here. Okay, so these are the thumbs here. This is the thumb is on the right side. Okay, this is the Cl. Okay, I'll draw Cl here. The thumb is on the right side, so wedge will be on the right side. The hydrogen is on the right side. This is the CH3 here, right? Now let us talk about this second carbon. Okay, this is the carbon number 1. This is the carbon number 2. Right, let us talk about this second carbon. For this second carbon, what you have here, you have this bromine that is on the right side. Okay, so what you see here, again, the thumb is on the right side. Okay, the thumb is on the right side, and the atom that is on the thumb will be on this particular line. Right, let us talk about, will be on the vertical line. And what about the horizontal line? On the horizontal line, you are going to draw the wedges and dash. Right, so now the thumb is on the right side. That means the wedge will be on the right side here. The wedge is going to be on the right side. That means CH3 will be here and H will be here. So this is your conversion of this wedge dash to the Fisher projection. So what they do, they give you the wedge dash projection and then convert it into the Fisher projections, because in Fisher projection you will be able to identify the enantiomer, diastereomers, all those things. Right, students? Right, students, everyone? Yes, bacha. Left hand side, ma'am. Can we rotate it in the line? Definitely you can rotate it. Okay, you can rotate it on the left head also. So I'll rotate it on the left side. Wait, let me rotate it on the left side. Okay, what you are going to get if you rotate it on the left side. Okay, if you rotate it on the left side, if you rotate it here, you will get A, this is B, this is D, and this is C. Okay, the dash and the wedges are going to be same, right? So convert it here. Now you have the thumb is on the left side, so wedge will be on the left side and the dash will be on the right side. Here you have B on the upside and A on the downside. So you can rotate this, you will get the same thing only. You will get the same thing only. You rotate this here, okay? You rotate A to this side and rotate it completely to 180 degrees. A to B, B to A, C to D, D to C. Rotate it to 180 degrees and you will get the same structure that you got from rotating it to the right or rotate it to the left. You are going to get the same structure here, okay? You are going to get the same structure whether you rotate it to the right or you rotate it to the left here. Yes, everyone? Is this clear to all of you? Students, is this clear to you? Students, is this clear to you, bacha? Okay. Now, let us jump to another topic. That is, okay, for example, you have, now you do this. For example, you have something like this. You have something like this. This is hydrogen. This is your CH3. Okay. Now this is this is your Br and this is CH3 again, right? Okay, so let us do this, students. Let us do this, everyone here. Okay, let us convert it here. Draw the 2 plus signs here for this carbon and for this carbon. The first carbon, this is the second carbon. For the first carbon, the thumb is on the right side. Okay, the thumb is on the right side. If the thumb is on the right side, that means this atom that is on the thumb, that will be here, right? And the atom, okay, if the thumb is on the right side, the wedge is going to be on the right side. That means bromine is going to be on the right side and CH3 is going to be here. Then, bacha, we are going to convert this one. Now here the thumb is on the left side. That means the wedge is going to be, wedge means the solid wedge here, okay? Not dash, the solid wedge here. That is going to be on the left side. So keep it here. This will be CH3. Okay, the wedge is going to be on the left hand side and this is going to be H. Okay, and this is going to be Cl. So this is going to be your final answer. Okay, this is going to be a final answer for converting this one to this one. Yes, everyone, any doubt here? Everyone, any kind of doubt in conversion of Fisher, Newman, all these things? Is this clear to everyone? So that after that, I can start with the conformers. Okay? Yes, bacha? Okay. Now let us start with the conformers. Okay. Now, bacha, what about the conformers? What about the conformers, huh? What about the conformers? It's very simple. Why? Because I am here to teach you. That's why it is very simple. Yeah. So what about the conformers? Conformers are different arrangements. Okay, they are different arrangements because of the single bond. For example, if you talk about a single bond, there is single bond between two atoms. So if you have single bond, if I am here and my friend is here, if I am rotating that friend, okay, I have that one stick in my hand, right, and he is holding that stick. Okay, so what we are going to do? We are going to, I can rotate that person here and there because we are linked by only one stick here, right? But if you have two sticks here, if we are connected like this, okay, if we are connected like this, now what is going to do? I'll say go this way, he'll say go this way, I'll say go this way, he'll say go this way. So this means when you are not single, there is restriction, but when you are single, there is no restriction, right? This is what happens in our real life. When you are single, there is no restriction, but when you are double, there is restriction. So that means they are saying that single bond has no restriction. Single bond has no restriction, right? If there is no restriction, right? If there is no restriction, that means that thing can move here and there. It means there will be change in the angles, and because of that change in the angles, there will be different conformers, right? There will be different conformers because when you are single, you are a free bird. You can move here and there and you will have different conformers, right? Okay, yes. Now let us see that how many conformers can exist. Bacha, how many conformers can exist? Oh my God, there are infinite number of conformers that can exist. How many conformers? There are infinite number of conformers, okay? Infinite number of conformers. Now you will say, ma'am, still we are not able to understand what is conformer, ma'am. Please teach that. What is conformer? I'll tell you, okay? I'll tell you. See, talking about methane here. If you talk about methane, I'll draw the methane structure here itself. Talking about methane firstly. See, conformers, methane means you have H here, you have H here, you have H here, you have H here. Okay, draw the Newman structure here. How are you going to draw the Newman structure? right? This is the Newmann structure. There will be no back carbon atom. That means this is not going to have any conformer, okay? This is not going to have any conformer here, because here we at least we need 2 atoms for the conformers. For the formation of conformers, at least we need 2 atoms. At least we need 2 carbon atoms, right? So you will say no conformers. No, very good bacha, no conformers, right? Who has write that? Rupoop, very good. There is no conformer for methane. We have no conformer for methane. Now let us do the next part. That is for ethane. That is specially mentioned in your NEET syllabus. Now let us draw this for ethane, everyone. How to do it for ethane? Now see this, beta. See this. How to do things for ethane. What is ethane? Ethane is CC. Here you have H, here you have H, here you have H, H, and here you have H, and again here you have H. Right? So this is for methane. This is for ethane. Right? So now let us draw the structures here. How are you going to draw? Draw the BMW here. Okay? Draw the BMW. I hope this is the BMW. Right? Okay? Right? This is the BMW. Now, BMW or Mercedes, whatever the sign it is, right? Now, is this BMW or Mercedes? Which is the sign of this car? This car is the sign of BMW or Mercedes? I can't recall that. My God, there is so much heat in this room. I'll die this summers. I'll definitely die this summers. Then who is going to teach you? But you are going to clear your MBBS right now. Why would you need me, no? Okay. So now here you have this carbon. This is the first carbon. This carbon is connected to, what I am going to do, this is the first carbon, this is the second carbon. This is the first, this is the front carbon, this is the front carbon, and this is the back side carbon. This is the back side carbon, okay? This is the front carbon, this is the front carbon, and this is the back side carbon. This is the back side carbon. So I am going to draw it here. This is going to be this one. Here you have 3 hydrogens, 1, 2, and 3. These are the 3 hydrogens. Then, bacha, draw the carbon of the back side. This is the carbon of the back side that will be connected to, that is going to get connected to with this one, and that is going to get connected to this one, that is going to get connected to this one. Okay, so now what we are going to do here, everyone? This is going to get connected to this one. Okay, so this is the hydrogen part here, this is the hydrogen part here, again this is the hydrogen part here. Sorry, let me draw it clearly. This is the hydrogen part, this is the hydrogen part, this is the hydrogen part. Okay, so there is a name of this structure. Again you can draw this structure. See the angle between this hydrogen and this hydrogen. See how this structure is. Actually this structure is something like this, okay? Actually this structure is something like this. You have Y here, then again in the back side you have same. See, back side you have same. In this case, this is the front one, this is the front one, and in the back side you have same thing, something like this, okay? Same thing, something like this. There is no angle between this one and this one. There is no angle between these two. That is the dihedral angle. Okay, so what I am going to write here, the theta is going to be 0 degrees here. Theta is going to be, bacha, 0 degrees here. Did you understand that? The theta here is going to be 0 degrees here. And what is the name of this structure, everyone? Very good. What is the name of this structure? This is eclipsed structure. Okay, this is eclipsed structure. Now let us draw the other structure. You have this BMW sign again. Draw it here. This is the hydrogen. This is the hydrogen. This is the hydrogen. Now let us draw. Let us switch this to 60 degrees. Now let us rotate the back side to 60 degree. Okay. Let us rotate the back side to 60 degree. Okay, everyone. I am rotating the back side to 60 degree. Here I am rotating it. This was earlier like this. I am rotating it like this. Earlier it was like this. I am rotating it like this. Okay. Now I don't have 3-4 hands. That's why I am not able to draw the Y here. Right. So this is the Y here. This is again the Y here. This is one Y, second atom, third atom. Now rotate this to 60 degree and what you get, rotate this to 60 degree and what you get, bacha, this is what you get, this is what you get here, this is what you get here, and this is the hydrogen, this is the hydrogen, and this is the hydrogen in this case. Yes everyone, is this clear to all of you? This is the hydrogen, this is the hydrogen, this is the hydrogen, and this is going to be the staggered structure here. This is going to be the staggered structure here. This is going to be staggered structure, and here theta is going to be, theta is 60 degrees Celsius, not Celsius, this is 60 degree, and which is more stable here? Now here you have this one atom here and the other atom in the back side of this. So there will be lots of repulsions here. There will be lots of repulsions here. That is why we say, that is bacha, why we say that this thing, this is staggered is more stable than eclipsed. Okay. Staggered is more stable than eclipsed structure. Right? Okay everyone, staggered is more stable than the eclipsed structure. Yes everyone, okay. Now let us draw it for, now everyone let us draw it for propane. Okay, now let us draw it for propane. Now let us draw it for propane. See, for propane everyone, what we are going to do? Any other angle, ma'am, always eclipse in 0 degrees. Bacha, this is what they have told you. You can rotate it at any angle, okay? You can rotate it at 1 degree, 2 degree, 3 degree. That is why we have written there are infinite conformers, right? Because there are so many degrees, you can't define every single separate structure for all the angles here. That is why we have just structures, defined structure for some angles. Like for 0 degree we call it eclipsed, and for 60 degree we call it staggered. Okay, right? Otherwise you have infinite number of conformers here, right? Okay, yes. Okay, now let us draw another structure, that is propane. Propane is nothing, this is but this one. Okay, this is H, 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 and this is CH3. Right? So let us draw it. Let us draw it. Firstly, you draw this BMW sign here. Right? This is my front carbon. This is my back side carbon. This is my front carbon. This is my front carbon, and this is my back side carbon. Okay? This is the back side carbon. For front carbon, I have CH3. This is hydrogen. This is hydrogen. Right? Okay. And for backside carbon, what you have? And bacha, for backside carbon, what you have? For backside carbon, everyone, you have this one. Okay. For backside carbon, this is CH3. Okay. For backside carbon, bacha, you have, if I want to draw it at 0 degrees. Okay. This is my H. This is my H. Right. And this is my H. Okay. This is my backside one, that is going to have 3 hydrogens. 1 hydrogen, second hydrogen, and third hydrogen. This is my first structure. Now let us draw another structure here with 60 degree. I am going to fix it here. I am going to fix it here. I am going to fix it here. This is going to be CH3. This is going to be hydrogen. This is going to be hydrogen. Now let us rotate it. Okay, let us rotate this to 60 degree. Let us rotate it to 60 degree. Now let us rotate it to 60 degree. Right? Okay. So now tell me what is the name of this structure? What is the name of this structure? Everyone here I have drawn 2 structures here. What is the name of these 2 structures? Similarly, we have the same structures as we have defined before. That this structure with 0 degree is called eclipsed. This is called eclipsed, and this one is called staggered. This one is called staggered. Okay, this one is called staggered. Now bacha, let us draw this. This is eclipsed and this is staggered. Okay, this is eclipsed, this is staggered. Eclipsed, staggered. Now let us define it for some other thing. Eclipsed and staggered. For that what we have, everyone? For that what we have? Okay, which is more stable? Staggered is more stable here again because it does not have electronic repulsions, bond-bond repulsions. Here we have bond-bond repulsions, right? Steric hindrance is present here. Now if I ask you one thing, which staggered structure is more stable? Which staggered structure is more stable? As compared to this one, okay, as compared to this one, this staggered structure in ethane is more stable than staggered structure of propane, okay, because of less electronic repulsion. If I say this is for ethane, everyone, if I say, why I have drawn it here, okay, okay, now it's fine, okay, if I write it here, staggered structure of ethane is more stable because of more stable than staggered structure of propane. Okay, staggered structure of propane. Right, everyone? Is this clear to you? Yes, bacha, is this clear to you? Yes, everyone, is this clear? Perfect. Yes, very good. Now let us draw it for another, that is butane. Very important. Okay, very important. Now let us draw it for butane. For butane, what we have? Butane is what? We have C, H. This is CH3, this is CH3, right? This is for butane, right? This is for butane. Now, what is the next thing, bacha? Now we have 4 structures for butane, okay? We have 4 structures for butane. Let us draw it, the 4 structures of butane. The first structure, everyone, here is going to be, draw this BMW here, right? After that, what we are going to write? This is the front, this is the back. In the front, you write it here, CH3, okay, I'll just lighten this. The pen should be, the pen tip should be small. CH3, this is H and this is H, right? Now, this is the back side carbon. Firstly, what I am going to see, this is very important. Firstly, I am going to overlap one CH3 and this back also, this should be CH3. Okay, so this is going to be CH3 and this is going to be H and this is going to be H, right? This is the case here, right, everyone? This is the first case here. Now the second case here should be, everyone, should be, yes, everyone, the second case here should be, this is BMW here, this is CH3, this is H, this is H, right? After that, draw this, this one, rotate it to 60 degrees. Rotate this back side to 60 degrees. This is CH3 here. Rotate it to 60 degrees. This is going to be CH3. This is going to be H. This is going to be H here. Right? Have we drawn 2 structures here? Everyone? Are you able to understand this? We have drawn 2 structures here, right? Are you able to understand this? How we have drawn these 2 structures? Because this question is very important. Why I am not able to do this? Okay. Now, Arey. What? Yeah. Okay, that is quite funny. Please. What is wrong with this one? You are hurting my ego now, okay? Now it's fine. Just, okay. Now, he sometimes do masti with me, okay? So now this is CH3, this is H and this is H, right? And now how are you going to draw it? This is going to be, rotate this to another 60 degrees and what you are going to get, this should be CH3, this should be H here, it should be H here, okay? You rotated this to another 60 degree, right? Okay, then the last one here, everyone, the last one in this, the 4th structure here is that, draw the BMW here, draw the BMW here. This is CH3, this is H, and this is H. Then draw this one. This is your 60 degree, rotate it to 60 degree. This is CH3, rotate it to 60 degree. This is H, rotate it to 60 degree. This is going to be H here. Right? Okay. So these are the 4 structures that we are talking about. Now everyone name these 4 structures. This is theta. Here dihedral angle is 0 degree. Here it is 60 degree. Here it is 180 degree. And here it is between, it's 6, 7, and 9. It's 90 degree. Okay. It is 90 degree, and here it is 180 degree. Here theta is equals to, no, 120, sorry. 120 degree, and here it is 180 degree. Right? And what is the name of these structures? What is the name of these structure? This is called fully eclipsed. This is called fully eclipsed structure. Right? This is called fully eclipsed structure. What is this structure called, everyone? What is this structure called? Everyone here, what is this structure called? This is called, wait, this is called half eclipsed, partial, or you can say partial eclipsed, or partial eclipsed or half eclipsed structure. Right? Okay? Yes? So this is called partially eclipsed, eclipsed. What is this one? Here CH3 and CH3 are anti to each other. So this is called anti-structure. Okay, this is called anti-structure. And where CH3 and CH3 are like at 60 degrees angle, they are called gauche structure. This is called gauche structure. So you have these 4 structures in your syllabus, right? Okay, that is not directly mentioned, but they can ask you this. Okay, these questions have been asked in your PYQs. Okay, so these questions have been asked in your PYQs. What are the 4 structures? Right? Everyone, is this clear to you how to draw these 4 structures? Here CH3, CH3. Rotate the back side CH3 to 60 degree. Rotate this CH3 to another 60 degree. Rotate this 60 degree to another 60 degree. You will have this CH3 will be rotated from 0 degree to 180 degree. Right? Okay, everyone? Yes, everyone, here, is this clear to you? Now, bacha, what is the stability here? Okay, what is the stability factor here? Everyone, what is the stability factor? Firstly, you have anti is the most stable. Okay, anti means anti. Okay, gauche means that, you know, young girl, like gosh, oh my gosh, she's like, oh my gosh, I'm like this. Okay, so anti is going to be more stable, no, because anti is more aged, right? So anti is going to be more stable here, right? Anti is going to be more stable. Then you have gauche, right? Then you have partially eclipsed, right? And then, bacha, you have the last one that you have is eclipsed structure. Okay, the last one that you have is fully eclipsed or eclipsed structure. Okay, this is fully eclipsed or eclipsed structure. You can say fully eclipsed structure. Okay, so these are the 4 things that matter to us, right? Okay, so these are the 4 things that matter to us. Everyone here, is this clear to you? Right? Okay. Yes, bacha. Very good, very good. Now, few questions, very important question for you. That is gauche effect. Now, what is gauche effect? Gauche effect states that if there is hydrogen bonding, then gauche will be more stable as compared to anti. Like, for example, if we talk about this one, if we talk about glycol, right? In this case, you will have something like this. This is OH, this is H, this is H, right? You have something like this. Now, this is going to be, the anti is going to be more stable here. That means OH here, we have H here, we have H here. Or, we can also write it something like this. Why I'm making you understand why anti is more stable. Okay. this is OH, this is H, this is H, right? In this case, you have this one where here you have Gauche, right? This is the Gauche structure, this is the Gauche structure, this is the Gauche structure here. Yes, everyone, this is the Gauche structure, this is the anti-structure. So everyone, this is the Gauche structure, this is the anti-structure, and this is the Gauche structure. Gauche, where these two main things are connected to each other at 60 degrees angle. This is at 180 degrees angle. Okay, so here what we write, which is more stable because of the hydrogen bonding of this H and this C. Here what we have, this is O, this is H. This again O, this is H. So it has hydrogen bonding. Because of this hydrogen bonding, right, because of this hydrogen bonding, Gauche is going to be more stable here. Okay, because of this hydrogen bonding, Gauche is going to be more stable here. Okay, bacha, because of hydrogen bonding in this structure, Gauche is going to be more stable here, right? Now let us do some practice, everyone. Write it in the comment section. Is this clear to you? Is there any problem till now? Gauche is more stable because of, for me tomorrow term 2 exam, this topic is also there. Okay, this topic is also there. That is perfect. That is perfect. They will definitely ask you this. Okay. So now, bacha, next thing that we have is, for example, they ask you, tell me out of this anti or Gauche, which is going to be more stable. This is your A structure. Talking about this one, you have, this is F, this is OH. Now tell me, in A and B, anti or Gauche, which is more stable in these two things? Anti or Gauche, this is the A part, this is the B part. Which is going to be more stable here? Okay? Yes, bacha, which is going to be more stable in the A part, which is going to be more stable in the B part? No, bacha, no. But why are you saying there is no stable, less stable? I am not saying which out of this which is more stable. I am saying in this which is more stable, anti or Gauche. In this which is more stable, anti or Gauche. Okay. Now, very good. In A you have anti is more stable because here we have no hydrogen bonding. We have no H bonding. No hydrogen bonding. Okay. No hydrogen bonding. And in this case, you have Gauche is more stable. Gauche is more stable as compared to anti because here you have hydrogen bonding. Okay. Here you have hydrogen bonding. So is this clear to all of you? It has hydrogen bonding. That is why it is more stable. Yes, ma'am. Can you read my comment? Definitely, beta. I can read your comment. Definitely, I can read your comment. This is that season in North India where you are just turning on the AC and turning it off every 5 minutes. Because we don't know whether we are feeling hot or cold. Okay. Yes, understood this. Yes, bacha. Any problem here? Any problem here? Should we jump to the next topic? Should we jump to the next topic? Yes, beta. Should we jump to the next topic? Okay, we have completed the conformers here. We will do the conformers of cyclohexane now. Okay, we'll do the conformers of cyclohexane now. Conformers of cyclohexane, what they can ask you, see this. What they can ask you in the cyclohexane, everyone, what they can ask you in the cyclohexane. For the cyclohexane, what we have? For the cyclohexane, what we have, beta? What we have? So, cyclohexane is like, we have 4 conformers here. First one is chair conformer. Okay, how to draw chair? Like you are sitting in the chair and relaxing, right? This is how you are going to draw it. This is the chair. This is the chair. This is the chair. Draw this, and draw this. This is your Twitter sign. This is your sign of Twitter. Is it? Yes? You can recall it by the sign of Twitter. This is your chair. Okay, this is your chair conformer. This is your chair conformer. Now let us do the sign for another one, that is your twisted boat. Okay, firstly let us draw for the boat. What is the boat structure here, everyone? What is the structure for the boat? How you draw the boat? How you draw the boat, everyone? How you draw the boat? This is how you draw the boat, is it? 1, 2, 3, 4, 5, 6. This is the boat structure here. Okay, this is the second conformer, that is the boat structure here. Okay, that is the boat structure. This is the second conformer, that is the boat structure. This is the chair structure. This is the chair structure, right? And this is the boat structure. This is the boat structure here. Chair structure, boat structure. Next structure, beta, what we have? Next structure we have twisted boat. For twisted boat you have to draw two kites here. Okay, you have to draw two kites here, right? Either you can draw it like this, or you can also draw it something like this. Okay, you can draw it something like this, something like this. Okay, both are correct. Okay, both are correct. This is your twisted boat. This is how you twist. You twist this boat. You just twisted this boat like this. Okay, then you get this structure. Right? That is your twisted boat. Now what is the third one, everyone? What is the third one? What is the third one, yaar? What is the third one? Staggered and gauche. Ma'am, what is the difference? Staggered and this very, like the difference is very large, beta. Okay, you're asking. See, gauche. See, gauche and NT are like other parts of staggered. Okay, this is also staggered. This is also staggered. Right? When we have hydrogen, that is called staggered. But when we have two same groups, same groups here and same groups here, in that case we will define it as gauche and anti. Right? It is like this anti and gauche are the subdivision of staggered. Okay? Right? But in this case we do not define stagger or this. This is also staggered, this is also staggered. For that, the specific name given to this one is gauche and the specific name given to this one is the anti. Okay? Yes? Okay. Now, bacha, next thing that we have is the boat structure, and this is the, draw the boat here, everyone. Okay, what is a half chair? Draw the chair here. Okay, draw the chair here. You're drawing the chair, you're drawing the chair, you're drawing the chair. Okay. You are drawing the chair and suddenly you thought that I don't want to have a chair. Okay, then you close this topic. Now, this is called the half chair. Okay, this is called the half chair. Oh, ma'am and ma'am's OCD is going to kill you guys. This is called the half chair structure. Okay, this is called the half chair structure. Right, this is called chair structure. Right, this is called boat structure. This is called boat structure. This is called twisted boat structure. Right? And this is called the half chair. This is called the half chair structure. Okay, these are the four structures that we have: chair, boat, twisted boat, half chair structure. Yes, everyone? Everyone here. Now, what is the stability order of this? What is the stability order? Okay, what is the stability order, everyone? Firstly, you want to be seated on the chair, okay? And half chair is the last. You don't want to sit on the half chair, the tutti footies here, the scrambled chair. You don't want to sit on that, right? Okay? So this is the half chair. Now, next we have, here we have twisted boat, twisted boat, twisted boat, and this is the boat structure. Okay? And this is the boat structure. So this is going to be your stability order. What they can ask you in cyclohexane, they can ask you the stability of all the conformers here. Which is more stable, which is less stable. Okay? Yes, beta. Which is more stable, which is less stable. Yes, beta. Any doubt here? Any doubt here? Yes, beta, any doubt here? Yes, okay. Double bond between atoms, where you have double bonds? No, beta. Conformers are only when there is single bond, no double bonds, okay? Double bond cannot, in double bond we cannot say that conformers exist, okay? Conformers only exist when you have single bond. As I told you, in single bond you have no restriction. When you're single, you can move here, you can move there, right? But when you have double, he will say, okay, move here. You will say, no, move here. He will say, move here. You will say, no, move here. So there will be restriction. You have to move accordingly, no? You can't say, I want this, you also want this, right? This doesn't happen when you get double, when you are a couple, right? So stay single. What chemistry teach you? Stay single, right? Okay. Twitter is the most stable. Yes, everyone is on Twitter, right? Twitter is the most stable. Okay, nobody wants to be on the boat and then in the river and all that. Nobody in the ocean and all that. Nobody wants that. Nobody wants this. Nobody wants this half chair, right? Nobody wants this. Everybody wants to be sit on the chair and then then have the kite show there and all these things. So firstly chair, then you have twisted board, then you have boat, then you have half chair. Okay, this is going to be your correct answer. Okay, bacha? Yes. Okay. Now we have completed conformers of alkane, ethane, butane, propane and cyclohexane. Okay, all the questions that can be asked from conformers, we have done that already, right? Okay, yes, sit in BMW. Yeah, this is what conformers say, that be single and sit in BMW. Okay, what does conformers say? Conformers say that be single, have single bond and sit in BMW. If you don't have single bond, you can't sit in BMW, right? This is what chemistry teach you, that you have to be single to be sitting in the BMW. Stay single, hashtag. Okay, now next thing beta, what we have, yes, right, chemistry rocks, right? Chemistry rocks. Chemistry will teach you the life lessons. It will teach you the life lessons. See what they tell you? Chemistry ma'am was saying that they will change the color, but you didn't get it. We're like, okay, the compound is going to change the color, but actually people changes the color. First chemistry lesson, that people change the color. They change their behavior. Second chemistry lesson, that resonance structure told us that if you don't change yourself time by time, then you will be very less stable. You have to grow in life. This is what resonating structure told us, that you have to change your position by time, right? You have to grow in life, only then you will be stable. This is what resonating structure told us, right? Okay, and what organic chemistry told us? Organic chemistry told us that bonds can be broken and new bonds can be formed, right? This is what chemistry teach you, beta. Chemistry rocks. Everybody in the comment section, right? Everybody in the comment section. Chemistry rocks. Okay. Now bacha, we have next thing, that is Stereocentre. Okay, that is Stereocentre. Now what is Stereocentre? Everyone? What is Stereocentre? Chemistry rocks. Ma'am rocks? Okay, ma'am rocks. Yes. Now let us see what is Stereocentre. So stereocentre means 2 into geometrical centers, geometrical isomers plus chiral center. Okay, these are the number of stereocenters. For example, I am going to draw something for you, right? You just define the stereocenter for that. Okay, first structure here is this one, that is CH3, CH, double bond CH, right? Double bond CH, then CH, then double bond CH2. How many stereocenters for this one, everyone? Now here you don't have no chiral carbon is present here. No chiral carbon is present here. You have one double bond here. You have one double bond here. Now this double bond is not the geometrical isomer. Why? Because here you have, in the geometrical isomer, if you have same atoms, on the same side, that is not the geometrical isomer. So this will not show geometrical isomer, this will show geometrical isomer. So this is going to be 2 into 1, 2 into number of geometrical isomer. This is going to be 2 stereocenters. Okay, so one geometrical isomer has two stereocenters, right? Okay everyone, this is the first example here. This is the first example. Now let us talk about the second example here. Now let us talk about the second example here. What about this one? You have Cl, you have OH, this is CH3, and this is C2H5. Everyone, how many stereocenter here? Everyone, how many stereocenter here? How many stereocenter are present here? Everyone here, how many stereocenters are present here? How many stereocenters are present here? How many stereocenters are present here? How many stereocenters? Here you have just one chiral carbon. So stereocenter is going to be 1. Okay, you have no geometrical isomers here. Just one chiral carbon. Right here, how many chiral carbon? This is a chiral carbon because this has different. Here it has 2 hydrogens, so no chiral. 2 hydrogens, so no chiral. Chiral carbon has 4 different atoms. So it has one different. This one is also different. C, and here it has chlorine. This one is hydrogen here. This one is hydrogen. So it has 2 chiral centers here. Okay, this one is the chiral center. This one is the chiral center. So stereo center are going to be 2 here. Okay, there are going to be 2 stereo center in this. Right, bachcho? Yes, beta. Now let us talk about another 2 examples. Yes, is this clear to you? How you define stereo center? Now, last 2 examples of this. 4th example, then 5th example. Answer me the stereo center for this. This is CH3, everyone. CH3, single bond CH, double bond CH, then you have C, then you have H, this is Cl, this is Br. Okay. How many stereo center for this? How many stereo center for this? How many stereo centers are present for this one? How many? Where beta? No GI will be present here. No GI will be present here. Okay? No GI will be present here. Right? Okay? So now this is going to be, yes beta? Now next is, here you have one chiral center, right? And you have, this is the GI. Okay? This is the GI. Right? This means 2 into 1 GI plus this is going to be 3. 3 is going to be the answer here, because number of geometrical isomers multiplied by 2 plus chiral centers, that is the stereo centers here. Okay, that is the stereo centers here. Right, so it is going to be 3. There are going to be 3 stereo centers. Yes, bacha, there are going to be 3 stereo centers. Right, okay. Now, next thing that we have is, you have CH3, right? This is CH, this is CH, this is CH, this is going to be CH3, this is going to be Cl, OH, this is going to be Cl, right? Okay. Now, next thing here is, what we have is stereo center, right? Stereo center, how many stereo center? This is chiral, obviously this is chiral, right? This is one different, this is also chiral, this is also chiral, right? So it has 3 chiral center, that means 3 stereo centers are present here, right? Now everyone, are you clear about stereo centers? Shall we move ahead with the last topic? Any problem till now? Do you face any problem till now? GI, where beta? Where? CL, same side. Beta, we have, Whenever we calculate this particular thing as a chiral center, then we will not calculate the same thing as the geometrical center. Okay, this has been calculated in the chiral center, so we will not calculate it with the geometrical center, right? Okay, now the last topic for today, bacha, is number of stereoisomers. Okay, number of stereoisomers, where n will be the system. I'll tell you how to calculate the system here. Okay, firstly let us see the formulas. So there are basically two types that are defined here. One is symmetrical, other is unsymmetrical. Okay, for unsymmetrical you have stereoisomers are going to be 2 raised to power n. The formula is going to be for stereoisomer is going to be 2 raised to power n, right? Okay, now for symmetrical, the n can be even, this can be odd, right? The n can be even, this can be odd, right? And the formula that we are going to apply here is going to be, everyone, the formula that we are going to apply here, this is symmetrical, right? This is symmetrical, right? The formula that we are going to apply here, everyone here, what is that formula? 2 raised to power n, 2 raised to power, everyone, 2 raised to power n minus 1, 2 raised to power p, right? Okay, this is going to be the formula. If n is even, then p is going to be n by 2, right? Okay, n by 2 minus 1, yes everyone. And if it is odd, p is going to be n minus 1 by 2, right? Okay, so just apply this formula, you will get your answer. I told you different formulas for geometrical isomers, different formulas for optical isomers. Now this is the formula to get total stereoisomers. Okay, this is the formula to get total stereoisomers. That the structure is symmetrical, then you have this formula. With n is even, you will apply p as this. N is odd, you will apply p as this. If you get unsymmetrical stereoisomer, that is going to be 2 raised to power n. Right everyone? Okay. Now let us draw the structures here. Let us draw the structures and understand this with the help of the structures. Okay, understand this with the help of the structures. Yes everyone, what is going to be the right answer here? What is the system here, ma'am? What is the system? Firstly, what is the system? Everyone, what is the system? What is the system here? Yes everyone, what is the system? In system, we calculate the number of chiral plus the double bonds, okay? If here this double bond and this double bond, 2 double bonds will be taken as 1 double bond only. 2 double bonds will be taken as 1 double bond only, okay? 2 double bonds that are together will be taken as 1 double bond only. So here we are going to take this as 1, right? And this is the chiral center, this is the chiral center. So n is going to be 3 here, okay? N is going to be 3 here. As this is unsymmetrical, so stereoisomer are going to be 2 raised to power n, that is 2 raised to power 3, that is 8. Yes beta, this is going to be 8. Okay, this is going to be 8 here. Yes students, any problem here? Any problem? This is the first question. Okay, the 2 chiral centers plus this 2 double bonds that are in alternate position will be taken as 1 only. Okay, they will be taken as 1 only. Right? Okay. Now, next question that we have, wait, that is CH3. CH, double bond CH, right? Same question. that we did for this one. CH, this is Cl, this is Br. So how many stereocenters were there? There were three stereocenters. Stereocenters were three. It had three stereocenters. But now how many stereoisomers? This is going to be one double bond, right? This is going to be one chiral center, right? This is going to be one chiral center, right? Okay, so n will be going to be 2, and here we are going to write 2 raised to power n, that is 2 raised to power 2. 4 is going to be the stereoisomer. How many stereocenter? That is 3. How many stereoisomer? That is 4. Yes? Double bond is considered as 1, and if it's something like this, it will be considered as 1 only. 2 but double bonds will be considered as 1. Okay? Here 2 double bonds will be considered as 1. Right? Okay? You will find different methods for this, but this is the simplest method to calculate stereoisomers. If they have considered this as 2 double bonds, in that case, what will change? Beta, what is going to change in that case? In this, only this one shows geometrical isomers, right? Only this one shows geometrical isomer. This does not show geometrical isomer. So this whole is going to be taken as 1. But just see this, okay? This, wait. Now, here you have one hydrogen, here you have one hydrogen here. This does not show geometrical isomer, so this will not be included in this, right? But here we will calculate, okay? Here we will calculate this one as the 1, this one as 1 center. So this is the difference between, I'm writing it here. When you calculate stereocenter and when you calculate stereoisomer n, that is the system, the number of n that you have, that will put in the formula. Here it is equals to, this is equals to, stereocenter is equals to 2 into geometrical isomer plus chiral center, but in this case n is equals to, that n that we are talking about, the system, that it equals to geometrical isomer plus chiral center. Here we do not multiply this by 2. We do not multiply this geometrical isomer by 2. Okay? We do not multiply this geometrical isomer with 2. Right? Okay? We do not. Yes? N is equals to 2. Symmetrical. No, beta. Symmetrical does not mean even or odd. Right? Symmetrical, we are talking about the structure here. Okay? Let me tell you. I will give you an example about it. For example, I am talking about this structure. This structure, can I cut this structure into equal halves? No. That means this is the unsymmetrical structure. This is the unsymmetrical structure. Can I cut this structure into equal half? No, I cannot cut this structure into equal halves. That means this is also unsymmetrical structure. This is also unsymmetrical structure. Right? This is also unsymmetrical structure. Right? Okay. So here, this does not show geometrical isomer. This shows geometrical isomer. These are 2 chiral centers. So n is going to be 3. Okay. How n is equals to 3? This is 2 chiral centers. This is 1 geometrical plus 2 chiral center is equals to 3. How this is 2? This is 1 geometrical plus 1 chiral center. 1 geometrical plus 1 chiral center, that is 2. Yes, beta? Any problem here? Now let us do one more example of this. Let us do one more example of this. Okay? Let us do one more example of this. See, here you don't see any double bond here, right? Bacha, always remember, if something is included in the chiral center, that will, even if that is making geometrical isomer, that you will not include that in the geometrical isomer. One carbon atom, either it can be included as the geometrical isomer or it can be included as the chiral center, right? This is what one person, that is Rupoop, was confused about, right? Okay, beta, Rupoop. So you understand why here I have not written. Here you are talking about that, ma'am. It will also show the geometrical isomer, but these are already included in the chiral center, so I will not include it in the geometrical isomer. Okay, one carbon can be included in the chiral or in the geometrical isomer. So here this is the chiral, right? This is the chiral, everyone. This is the chiral center, right? Okay, this is the chiral center, this is the chiral center. So N is equals to 3 chiral center, no geometrical isomer, right? So this is unsymmetrical, this is unsymmetrical. So I'll write 2 raised to power n, that is 2 raised to power 3, that is 8 is going to be the correct answer for this, right? 8 is going to be the correct answer for this. Yes, everyone? Now let us do for the last one. Yes, okay, Kunal. Okay, Kunal. Now you understood why I have not written geometrical isomers there? Yes? Now this is the last question for today that we are going to do. Last question for today, where you will understand what is symmetrical, right? CH2H5, this is C double bond C, right? Okay, right, CH double bond CH, this is CH, this is C2H5, this is CH3. Now can I cut this into half? If I cut this here, they will be divided into equal halves. That means this is your symmetrical, okay? This is the symmetrical one, okay? That means this is the symmetrical one. If now this is the symmetrical one, beta, if this is the symmetrical one, how you going to write it? How you going to write it? Is this the chiral center? Yes, this is the chiral center, okay? Is this the chiral center? Yes, this is the chiral center. Is this double bond showing geometrical isomer? Definitely, because this carbon, double bond carbon, it has one hydrogen and one different group. One hydrogen and one different group. It means you have different groups on the same side. It will show geometrical isomer. Here you will write this is going to show geometrical isomer, and here you are going to write that symmetrical. Here you are going to write N is equals to 1 geometrical plus 2 chiral center is equals to 3. But this is symmetrical and N is odd. When you have N odd, in that case, P will be equals to N minus 1 by 2, that is going to be 3 minus 1 by 2, that is going to be 2 minus 1 by 2, that is 1. Okay. Now what next? Now beta, what next? You have P here, you have N here. Then beta, what you have next is, apply the formula, that is 2 raised to power N minus 1 plus P 2 raised to power P, right? Okay, that is going to be, this is the stereoisomer, that is going to be 2 raised to power 3 minus 1 plus 2 raised to power 1, that is 2 raised to power 2 plus 2, that is 4 plus 2, that is 6. Okay, 6 is going to be the correct answer here. Yes, everyone? Okay. Yes, just apply this formula, you will get the answer. Right, this is what I was talking about when I said symmetrical and unsymmetrical. Symmetrical means cut this into equal halves. Then this is symmetrical. This is not, you cannot cut this into equal half. Right, there is no plane of symmetry present here. That is why this is unsymmetrical. Yes, everyone? Is this clear to everyone? Yes, bacha? Is this clear to all of you? Now there is a special surprise for you by your favorite Shreya sir, that he is coming to, okay, he is coming to, wait, where is this name of the city? Wait, oh, that is actually mentioned here, okay, yeah. So he is coming to Hyderabad, Telangana, right, for you, right, and what we are going to do to meet him, right, what you need to do to meet him. Now what you need to do here is, you just need to register yourself. The link is in the description. I will show you the link in the description. Just wait. Okay. Shreya sir is coming to Hyderabad. Fill the form here. So this is the form. Just go to the Google and fill your form here. Okay. Fill your form here, beta. This is 24th of March 24th of March, Shreya is coming to Hyderabad Nizamabad. Okay, so just fill this form, enter your grade, what you like to do and all this, where would you like to attend the event and all that. Fill the form and get yourself registered to meet Shreya sir. Okay, right? Okay, and if you find any difficulty in that, just contact on these numbers. Right? Okay, beta. Next is beta our crash course that is valid for you. The crash course is valid for you. And just if you want to go into offline centers, there are the prizes. And if you want to get enrolled into the online courses, that is just for 2,000 rupees. Okay, just for 2,000 rupees, you will get enroll yourself to the online session. And if it would be best if you want to get enrolled to the offline sessions, right? Okay, but and in the online session as well, if you don't live nearby the offline centers, then you don't need to worry about that, because for that you will have more things, that is 17 all India mock tests, 20 practice tests, and then you have your chapter wise tests and assignments, very important, that is needed for those chapters where you're doing so many mistakes, right? Okay, then bacha, you have unlimited doubt sessions in the Vedantu's doubt app. Then you have Tattva and summary notes, right? Tattva and summary notes. For that you will get the summarized note, the handwritten summarized notes for yourself. So is there any problem here, bacha? Is there any problem in doubting all these things? Yes, bacha? Yes? Okay, so you just need to enroll yourself into this and you will get these are your teachers. And how you get enrolled into this? These are our all India rank holders from NEET 2023. You can see I want all of you to be your name on this page, right? Okay, I want all of you to be on this page. And here is your NEET crash course, which is valid, now. Just need to go to this, view the plans, and here you will have the crash course, right? Okay, and here you will have the crash course here. Okay, bacha, here you will have the crash course applied here, right? Okay, everyone. Yes. Okay then, bacha. Bye bye. Take care. See you all in the next class, that is tomorrow at 1 p.m. Okay. Tomorrow your class is at 1 p.m. where we are going to complete the full syllabus, where we are going to do redox reactions plus electrochemistry plus electrochemistry. Okay, we are going to complete it at 1 p.m. Okay, I am going to get live at 1 p.m. where we are going to complete redox reactions and electrochemistry along with the practice questions. Okay, along with the most important practice questions here. Okay, ji, definitely you will have your name here someday. Yes. Okay. Okay then, bacha. Bye bye. Take care. See you all tomorrow at 1 p.m. for redox reactions and electrochemistry. Take care of yourself and good night.